All right, welcome to the Explainer. Today, we're going to do something really cool. We're going to build a simple, but honestly, a pretty powerful malware detector. And in just a few minutes, you'll start thinking just like a digital detective. So, just so you know where all this is coming from, everything we're about to cover is based on this fantastic lesson from eLearn Security called Yara and Yara Rules. This isn't just theory, okay? This is a real-world peek at how the pros get it done. Okay, so let's start with a classic cybersecurity problem. Imagine this. You've got two malicious files, and they look really similar. So how do you write just one single signature to catch them both? I mean, this is a huge challenge, right? Malware authors are always tweaking their code just a little bit to sneak past defenses. Kind of like a master of disguise. Our job? To see right through it. So let's dive in. Okay, so our main tool for this malware hunt is something called Yara. And let me tell you, this thing is an incredibly powerful piece of software. It's pretty much the industry standard for malware researchers. So, what is Yara? Well, the best way to think about it is like a Swiss Army knife for pattern matching, especially for malware researchers. Basically, a Yara rule is like a unique fingerprint. We're going to create a description of what the malware looks like, what kind of text or code it has inside it, and then Yara goes and scans files to see if anything matches that description. Simple as that. Now, look, you could try to sift through a file for clues by hand, but trust me, that is incredibly slow and super tedious. So, to make our lives easier, we're going to use a tool to automate that first super important step of our investigation. The tool we're going to use is a handy little Python script called Yargen Py. Its entire job is to look at a piece of malware and then automatically spit out a basic Yara rule for us. It does all the heavy lifting, which means we get to focus on the fun part, the analysis. Running it is super easy. You just use the command yargen.py with the -m flag. That just stands for malware path. And then you point it to the folder where your malicious file is. In our case, the file is called junkfilescleaner.exe. Okay, so as the tool is running, you might see something that looks a little scary, a memory error. Now, I know that sounds bad, right? But in this case, don't worry about it. It's just because the tool is trying to load a really big database in a low memory environment. The important thing is, the script still works just fine, and it's going to generate that first rule for us. All right, the tool did its thing, and it's created a file with our very first Yara rule. So now it's time to put on our detective hats and really dig into what these first clues are telling us. And what's really cool is how a Yara rule is put together. It's actually pretty simple. There are three main parts. You've got the meta section, which is just for descriptive stuff, author, date, things like that. Then you have the string section. This is where you define the actual fingerprints you're looking for. And finally, you've got the condition, which is the logic that says, okay, if you see this and this, then it's a match. And wow, Yargen found some amazing clues in our first sample. Just look at this stuff. We've got Microsoft, a classic misspelling of Microsoft. We've got a suspicious log file path, c/system.log, and my favorite, the phrase key grabber. I mean, that's not subtle, right? These are fantastic indicators. So if we look at the condition the tool created, it's actually really, really strict. It says a file has to have a specific signature, the MZ signature. It has to be smaller than 20 kilobytes. And this is the most important part. It has to contain all of the strings from $S3 all the way to $S9. Every single one. Okay, so we've got our rule. We think we understand the clues. Now it's time to test it. This is really the moment of truth, where we find out if our initial fingerprint is actually any good. So we're going to run the Yara command. We just point it to our new rule file, and then we point it to the folder that has both of our malicious files in it. And here we go. This shows our problem perfectly. Look at the results. It caught the first file, junkfilescleaner.exe, no problem. But it totally, completely missed the second one, 12345.exe. And we know for a fact that these two files are related. So what gives? Well, it looks like our first lead just went cold. And hey, this happens all the time in cybersecurity. It just means we have to go back to the evidence, take another look at our clues, and figure out exactly why that rule failed. So the big question is, why did it miss the second file? What's so different about 12345.exe? What piece of the puzzle is it missing that made our super strict rule just fly right by it? Aha! So after a little digging, we found the culprit. Remember that super strict condition, the one that required all of the strings? Well, it turns out the second file was missing one of them. Specifically, it was missing the string assigned to $S7, which was that Microsoft misspelling. Our rule was just way too specific. So, what's the solution? We've got to edit the rule by hand. We're going to make it less specific. We'll get rid of the strings that only show up in one of the files, like that $7s one, and instead we'll focus only on the clues that they both share, things like key grabber and that c/system log path. We'll also rename the variables to make it a little clearer, and then save our new improved rule. Okay, we have our new improved fingerprint. Let's run this test again. Time to see if our smarter, more refined rule can finally finish this hunt. We're going to run the exact same Yara command we did before. Nothing changes there. The only difference is, this time, we're pointing it to our new, more flexible rule file. And success. Look at that. Both junk files cleaner.exe and 123545.exe are now detected. We got a positive hit on both of them. See? By looking at why we failed and making our clues a little bit smarter, we built a rule that catches both versions. Case closed. So, what are the big takeaways here? Well, for one, automation is a fantastic starting point, but it's not the final answer. A good rule needs to be specific enough to catch the bad guy, but also broad enough to catch his cousins? And maybe most importantly, cybersecurity is all about this cycle. You test something, you fail, you learn from it, and you make it better. And just like that, you know how to build a malware detector. So if you found this explainer valuable, please do us a huge favor and hit that like and subscribe button. It really does help us keep making more of these for you. Thanks so much for watching.